Okay, let me introduce you Group 8. There is two members. One is Vaishnavi Subramanian, that's me, matrix number 8 and 220192. And then we have Muhammad Irfan Fadli, whose matrix number is 8 and 220132. We are both BNE students, section 2.
So for the introduction, the primary objective is our project is to design and to implement the profession of safety measure for PLC based motor control system, and using the star delta method, which is the objective is to develop a strong theoretical foundation and principle of star delta, starting method and their application, introducing starting current in three-phase motor. Next is to enhance practical skills in electrical circuit assembly, so and troubleshooting and testing. The next one is to improve our problem solving skills and ability by identifying and issue that arise during to design and the testing process for the star delta circuit.
Assalamualaikum, kami dari grup 10. Saya akan bercakap tentang control circuit. Untuk circuit ni kami ada MCB, ada 3 contactor. Yang ini ialah main contactor kami. Ini ialah star contactor dan ini ialah delta contactor. Ini ialah timer. Kami setkan timer pada 5 second. Ni butang start, stop, dan ni indicator light, run and straight. Ni lah Tor. Okay. Kita tanya macam mana litar ni berfungsi. Onkan dulu. Onkan yang ni. Single phase. Selama 5 second delta akan aktif right. Ini sekarang tengah right, so kita stop. Sekarang kita tekan test untuk trip.
Jangan ada gigi ni. Tak sedia ada semacam apa.
Okey, okey, dah trip. So kita tekan hijau ni untuk reset dulu. Ni tandanya dah trip. So kita reset dia. Okay, dah reset. Okay, dah reset. Sekarang untuk 3 phase pula, untuk kita gerakkan motor ni. Kita onkan 3 phase. Kita onkan dia. Pada 5 second. Speed dia sepatutnya ketambahan. Okay, stop. Tunggu dulu motor berhenti. Okay, motor dah berhenti. Dan untuk trip pula. Okay, sekarang kita ada trip. Kita reset dulu. Itu saja daripada grup kami. Terima kasih.
Alright, so I'll be discussing our motion sequence diagram. So initially, before we draw the diagram, we need to decide which is our output and which is our input. So as for our input, we have the start button, then the stop button, and then the timer. And then for our output, it would be the timer running, and then our main contactor, delta, star contactor, and then our lamp, right? So if you see our motion sequence diagram, you can see each and every component has an address uh, with the channel that it corresponds to lah. So for start, we have assigned 0.02, stop is 0.04, and then for timer, we gave it 5 seconds. So the change from start to delta is 5 seconds. Main, we addressed it to channel 100. Start is 100.01, sorry, 100.01, and then lamp is 100.04. Start is 100.01. Delta is delta is 100.03. So this is our wiring diagram. There isn't much to discuss because after our motion sequence diagram, we know which component is just which address in the PLC. So from that on forth, we just have to connect the said component to the addressed value. And since we had already done our single phase board, we used somewhat similar wiring diagram. Just added 4 relays and a PLC to the system with the smaller blue color wire. So whichever is related to the PLC, they were given PLC wires. And then we made sure all the comms were connected and the neutrals were all connected, so there's no tripping or unnecessary short circuit. So now I will talk about our PLC program that is labeled, right? All the rounds are labeled, right? So now you can see that our round 0 has stop, start, and main, but there's latching from start to main. It's just so when you press start, you don't have to constantly press start. Like you can let go, and it will run. The program will run. So the main is the main is connected to the timer. So when the main runs, the timer will start to count down from 5 to 0. When it counts down, during the time it counts down, star will run. So star will run, main and star will run for 5 seconds, right? So after the 5 seconds, the timer will trigger delta to run and star to de-energize. So at this point, after 5 seconds, main and delta will be energized, star will de-energize. So during this time, we can reduce the load it takes, the stress the motor goes through by giving, how do I put this? Like, we don't start off the motor with like a very high current and like jerk it off, right? Okay. And this system will continuously run until you press stop. When you do press stop, the system will reset. This page shows a final product with the labeled hardware, and this is as clean as we could make it. And you can see that the circuit breakers are connected properly, and it leads to our main contactor, which is connected to our pole. And then from our main, you can see it runs to our delta and then star. You can see our 4 relays right next to our delta, and the ones connected with the blue wire is our PLC, and we also have an AC to DC converter. This one will ensure that the current is properly converted and not blow up the whole board lah. And then we also make sure our groundings and our neutrals are connected properly. And all the screws and wires were tightened because our previous error was we had loose wiring and the whole system wasn't working.
We are from 8 and my name is Muhammad Irfan Fadli. My matric number is AN 220132 and this is my partner Rashid. Kami nak tunjuk macam mana letak star delta yang ada PLC. Jadi mula kita on dulu. Okay. Dan single pole. Dan kita onkan dia. Ini no motor. So for 10 second delta tak charge dan start akan charge sekarang dengan main. Dan lepas 10 second start akan dinyah charge dan delta sekarang charge. Dan lampu indikator run menyala. Dan stop. Sekarang kita akan test untuk trade pula. Trade circuit. Tekan start. Sambil juga tunggu 10 second. Okay, itu kita tarik. Okay, sekarang trade punya lampu menyala. Maknanya dia tadi sedang trade. Itu kita decide. Tekan hijau. Okay. Sekarang kita pindah kepada motor pula. Kita on 3 phase. Kita motor start. Motor move brake. Explosive brake. Lampu raya atas dan motor tetap fungsi. Pelanconnya ni tetap sama. Currentnya di berbeza. Go.
Alright, so now I'll demonstrate how our PLC works with our Star Delta and with PLC, right? So if I were to press stop, we'll start with the easy ones. Stop, you can see it energizes and de-energizes. Did you guys see that blinking? Alright, so now I will go with our start so you can see how our program runs with our timer included, alright? So I'm going to press start. I will do it without the motor first. Alright, I'm going to press start. You can see that our timer gets activated and then it's counting down. After 10 seconds, and you can see our delta is activated and our lamp is running. It's on. So that's it. And when I press stop, the system is closed. I'm sorry, the system is down and our PLC returns to normal. Alright, thank you.
Right. In conclusion, the project effectively illustrates how advanced automation technologies can be integrated into motor control by implementing star and delta starter circuit, making use of PLC. By using PLC, the timing of switch between star and delta can be precisely controlled, allowing for programmed controlling. Okay? This resulted in optimal performance and decreased mechanical and electrical stress during motor startup. Improved control capabilities were made possible by PLC programmability and flexibility, which also made it simple to add new functions like remote monitoring and defect detection, and also modify timing parameters. We learned a lot about circuit design, PLC designing, real-world implementation of motor control techniques during the project lah. Okay, when the project was being completed. The Star Delta starting circuit successful implementation and testing brought to light that the benefits of adopting PLC implementation in the industry, such as increased scalability, easier maintenance, and reliability. In summary, the addition of PLC to Star Delta starter circuit not only accomplished the main goal of the project, which was to lower the starting current of the motor, but also to demonstrate the advantages of contemporary control system in improving effectiveness, usefulness in electrical installations. This study provides a strong basis for future research and implementation in variety industry control scenarios.